Okay, so this talk will be recorded, so please leave yourself muted and off, video off, unless you would like to be in the video. So yeah, Unianta, what's your background with software? How is it used in your daily life?
Yeah, like in my research group, our group is actually called Information Technology and Automation. We basically apply different information technology and software in the vertical domains of industrial automation. So myself, even though my background is a lot in electronic engineering, but actually during my PhD, my PhD thesis involves a lot in development of software library for development of embedded systems. And also this also actually what leads me to this kind of like involvement in this research software issues and topics. And I think this also why we're discussing about this making your software useful discussion, because in academia, different labs or research groups, they use some sort of different forms of software, and many domains of science nowadays, they use some sort of software in some extent. And it is expected that if you're working or developing a scientific software, you would need some domain specific knowledge for that. And for example, like for me as myself, if I was in the area of electronic engineering, I won't be able to develop, let's say, a software for quantum physics solver. That's not going to work. And the same otherwise, if you're working in quantum physics, then probably it's going to be very difficult to create a software that would work in industrial automation or something like that. And yeah, I think in this research software, like those who work in academia, they know that there is this publish and perish model, where basically researchers, they need to publish, otherwise they might lose their job or careers. Yeah. And in publications, scientific papers, articles, they're usually peer reviewed, but when you have a scientific work, where the result actually depends on software code, then this code is not usually peer reviewed. And I think, in my view, like this also contributes to the issue in this research software topics that, for example, as my experience back then, when I want to develop a certain library that uses someone else's library, I have difficult time in, let's say, understanding what particular methods actually is doing. And like for me, I have to spend a lot of time just to, let's say, read the code and even execute it myself, and then trying to get the hang of it, like what it actually does. And I think this kind of experience is shared by many people who are also experiencing these issues in one way or another.
Yeah. Would you say that your software is as useful as it could be? Because I know mine certainly wasn't.
Yeah, that's a good question as well. I think because that depends very much on actually what you're working. If your software is very specific to solve certain cases, then compared to, let's say, if for other software which is, let's say, aim for more general use, then of course you would expect or see many people would, let's say, fork your Git repo or reuse it in some other ways, or cite it somewhat. But still, like, if assuming that you want your work to be used by someone, or you expect your work to be used by someone, then it's going to be very difficult if we don't put enough information about what our implementation is actually doing. And even for ourselves, let's say, if we want to reuse it again in the next 3 months or even 6 months, I want to remember, like, I want to use this again, but I cannot recall exactly what this code is actually doing, or how do I reproduce the right steps to run this again. Or even for your colleagues or for your own supervisors. Let's say if they want to run themselves out of the code out of curiosity, let's say, then that's gonna be a bit difficult for them. So I think these are some of the issues in visual software that many would experience, at least in one way or another.
Yeah, I know when I was primarily a researcher, I considered my software to be better than most, but even then it's not reusable now, and it was not done very well whatsoever. And I see the same problem these days with almost everyone I work with. So we have a Presimo here, which you can open in a web browser, and you can give some discussion comments if you have any stories you'd like to share about what about your software background, either good or bad stories, and so on. And you can also ask questions, and we'll get there at the end. In the meantime, I will start a screen share here. So, yeah, so here's some initial starting questions. Yeah, and well, as it says here, you ever felt like your work is built as a house of cards ready to crash down anytime? Have you ever felt that way? I sure have. There have been times I've hoped that no one will be too interested in my papers, because then someone might try to use the software and who knows what they might find there, which is really a very counterproductive way to do things. I guess, are you pretty efficient in what you do? Like, do you feel that you're efficient in your software work?
This is also an interesting question. Like, I think it's for academia ourselves, who probably many are not trained as a software developers formally. Like, we just, let's say, try to implement or develop our code based on, let's say, what we learned to some extent in our previous, let's say, courses, let's say, normal traditional programming courses, if we happen to attend one, or if you're more like a self-trained, let's say, attending online courses somewhere, and then we learn how to use certain, let's say, functions, certain methods in Python, for example, and then we try to put things together somewhat and see if it will lead to something that works. But then, of course, it also, let's say, it still presents like some concern whether it is robust enough, or how robust it is, let's say, whether we can, let's say, execute it in a way that it will produce consistent result at all time, or is there any, let's say, certain drawbacks that we are not aware of because we don't, let's say, properly design it beforehand. So that's like one feeling that I have, let's say, when I was working on a lot in this software task.
Yeah. Do you ever think that scientists should take normal software engineering or development courses?
That's also a matter of like questions of, let's say, for me at least, that whether you have or are dedicated to allocate time to perform this, because I'm aware that academias, they have a lot of time on their hands already, but still, like, having aware of these practices in a way is an investment, at least for me, in my view, that you put a lot of efforts in the beginning and then it will pay back later at some point. Because let's say if you try to employ certain practice of good documentation, let's say you document properly of your implementation, you one would allocate time for this in the beginning, but then at the end, later on, when I want to do something again about my implementation, then I can retrace everything and reproduce it much easier compared to if I don't have that much information before.
Yeah.
At least that's how I view it. What about you, Richard?
Yeah, so, I mean, sometimes I talk to people and they say, oh, we have software development, software engineering courses, but while they may be good ideas, in practice, it doesn't really mesh with the scientist mindset. So this is basically a profession about making software, but most of us, our profession is doing some science and the software is secondary. So I think one of the biggest problems is that people will say, okay, here's the right way to do things, but the right way is just far too involved to be practical for a typical scientist to do. So it's like we're too perfectionist in things. And that sort of comes to this point here, the production versus research code. I mean, we can be honest, like most research software is not something that is going to have huge demands placed on it in the future. So a person may write many small pieces of software, and then only a few of them become actually useful in the end. And if we spend too long developing everything, then, well, it just is not really like, it's not a worthwhile investment. But there is some sort of minimum investment necessary to keep from having things become completely chaotic. So yeah, so after years of trying to teach people the right way to do things, I realized we can't tell people to do things the right way. We have to tell people to do things some way that's good enough. And that's when I invented this research code pyramid here. So the basic idea is that some people take and everything they do is a sort of hack, like you see here. Like your code is sort of some stuff you made, and then that's built on other stuff you made a few months ago, which is built on other stuff you made a few years ago, and the whole thing might fall down at any time. But the other option, which is telling people to do things perfectly, like here, it's too much work. Like for something that you're doing right now as a test, trying to do it perfectly is just too much, and people know that. And they just say, okay, well, setting up a full pull request project with contributing guidelines and all that for something which I'm only doing now for this week, it's pointless. So instead, there's some sort of balance. So the stuff that is least important, you put the least amount of effort in. And as you make something and it becomes more and more reusable, then it becomes more and more, it's something that it's built better and better. And then you're sort of in this good state here. So that's why we're here now. So what we're going to do is go through a lot of different aspects. And instead of saying what you have to do in order for things to be perfect, we're going to say, here is a good strategy. Like here's the different strategies you might use. So starting with the simplest thing, and then ending with the most complex, technically perfect solution. And it's up to everyone to decide the right solutions for you. So do you have any thoughts on the strategy? Like, do you have some sweet spot that people have, like people use in your group?
Yeah, so those are interesting points. Be correct. I think that's like one of the main fundamental requirements that needs to run as it is supposed to. Mm-hmm. Change without too much more difficulty. That's like another aspect that, let's say, if we're using, let's say, object-oriented programming language, which you can develop your own, let's say, classes separately, make your code more modular, so it's easier to change in the future. Then be run again once reviews comes in. So this is also one kind of like experience that I mentioned before, that after you develop something in like 4 or 5 months, 6 months ago, then you want to try it again. Can you actually recall what are the steps and what are the parameters and configuration that you put to actually produce these certain results? So This is particularly important, let's say, as when the review comes in, whether it's for a journal or even in PhD defense as well. Like this question may actually come in from a very curious opponents.
Yeah, it sounds like you have a story here.
And ideally not wasted once you do something new. Yeah, so it's again, like it's whether you work on something, you have invested a lot of time to work on something, and then you hope that it pays back somewhat. Either it gets cited very often or reused by someone, at least to some extent, or reused by your students in the courses. It's not like it's gonna be, you know, put in an archive in a website somewhere and then it will gain dust.
Yeah. Yeah. Okay, let's see. So yeah, so what we'll do for the rest of the talk is we'll go over these different kinds of topics, things that you can improve. So for each of them, we have a Presimo poll to ask you how you think you're doing right now. And so we can sort of see the basic background of things. And then we'll discuss, well, sort of what we do in practice and some good examples about different things. So I'm going to show the Presimo here. This is a smaller window. And we'll start with our first topic, which is how do you use version control? So, version control. So what is version control? So it's something that lets you track your changes in progress. So the classic case that I use here as an example is I have my code, I'm working on it, and then I change something and I come back tomorrow and suddenly nothing works. Like either it just doesn't run or it's giving some wrong result and I have no idea what I changed. And in these cases, if I'm using version control, I can exactly see what the differences between yesterday and today are. And if I'm not, or in most of my cases, I was using it, but I said, well, I want to use this perfectly. And I ended up not using it at all. So I had many days or months of changes altogether. So I didn't know what I had actually done recently. And then you're sort of stuck. This is really the worst feeling to be in, where something you know worked and you change something, you have no idea what, and it just doesn't work. So version control is well known for things like GitHub or GitLab or Bitbucket or different sites like this. But it's actually not so complex. So you can use version control just for yourself on a locally. So you don't need any server, anything. If you're using the Git version control system, you can just type git init, and then you've made a repository, and then you do git add and git commit every time you want a checkpoint. And then you've basically got the record of what you've done. And even if no one else will ever see this, the mere fact that you can go back to some other point in time is immensely useful. And should you say even completely required for something to be considered real science. If you go more advanced, you can have things like a shared repository and then multiple collaborators working on it. So you can actually share your code among other people without emailing it to each other. And if you want to be really advanced, you can use something called pull requests or merge requests, which basically allows anyone in the world to make a contribution to your repository. And all you need to do is review it and pull it, which has really changed the way that modern software is done, as GitHub's tagline is social coding. So Urianto, what are your thoughts here? Like how what kind of levels do you see as useful for your projects?
At least from the experience that we try to like apply this practice of version control, we use it in different levels. So, but now previously it was like a lot of our work was not in version control, but we try to, let's say, use this version control, apply it in some way. So we have most of our repos are local, commit for ourselves and for archiving purpose. But for certain other projects where they actually like in a way that they collaborate a lot, they actually use it in level 2, for example, as shown in this in the slide. So here we actually kind of like work with the students. Actually, these are repository or a project done by students, a group of 4 or 5 people. They use this repo and they actually put commit together in the same repo collaboratively and use this until the end of the project. And at the end they produce this implementation, and then but for this level 2, like this is a private repo where let's say you don't want a lot of risk. Let's say if you perform something incorrectly, let's say if you publish something unintentionally that it should not be published, then having a private repo would be a much better option. And then once you have your work finalized and everything, make sure that it doesn't it complies with all of the rules, then you can put it in public repo as an archive. So that's kind of like one practice that has been kind of like used in our group. What about you, Richard?
Yeah, so, well, the group I used to be in, towards the end of my time there, we got things set up with public and private Git hosting, both the Alto GitLab and public GitHub, and some projects there. But I think now that I've left, I'm not sure anyone's really using it. And most people, I'm not even sure if most people are using version control for themselves, which I think really shows how important it is that that you have close support to help you do these things. So how do you use version control? I see you use Git here. Do you use it from the command line, from the development environment? How would you recommend someone to get started?
For the case of these students, like they actually use the command line, but I think most of them use command lines, but we also introduce another option to use like the interface with the GUI as well. I think there are a lot of tools like that that provide some sort of visual interface. And so you don't have to type the commands yourself. You just point and click, and then it will execute the right Git command for you.
Yeah.
So there are different ways, I think, nowadays.
Do you have a recommended graphical tool?
For me, like I use this Git for Windows. I use like that one I'm using with my workstation. But for Linux, like if I'm using Linux, mostly I'm just using in a terminal interface. So for that one, like I'm just purely using script. But that very much depends on the situation and how comfortable you feel in using the Git.
Yeah. So next up is modular code, and you can see it's on Presmo again. How would you even describe modularity in code? I think for me, I would say it's basically packaging things or making things in small enough units that it can somehow be reused into multiple things without copying and pasting. How would you describe things?
If I can play a bit imagination, I can think modular code as some sort of like a Lego. where you have like those smaller pieces together. You can pile up them and combine them together into different things. And whenever you want to change something, you can just detach it and then reattach it with different components. So that's probably one illustration that I can think of.
Yeah, well, my general strategy here that I found has been quite helpful. When I start a project, I have no idea what I'm doing, so I just do it. But over time, the project gets a little bit more stable and I see some functions and things which are reusable. So I split them off into functions. And then over time, these functions become standard. And then I split them off into a separate library. And then this library is actually documented, actually using Gitwell, usually is public. And then they start using it in multiple projects. And this sort of saves the effort of too much upfront work. And I don't add anything to the library and make anything reusable unless I actually have a need to do it. So I see only 2 votes here about the modular code. Remember, everyone, please open this Presimo link, which you can see right here. And I'll put in chat again, and please vote on what you think. So, yeah, no examples for modular code. I don't even know how to represent that very well. And next up is organizing workspaces. Let's see. So, so how organized are your workspaces? So how would you describe this? It's again one of these things that I sort of have a feeling about, but it's hard to explain.
I think for me, it's also likewise. Like, I think different kind of like groups or organization, they have their own structure or their own ways of organizing things. So I think that reflects pretty much why in these slides, like, doesn't mention specific sources, although there are various recommendations if we're looking around, but that very much depends on the situation of your group and the work itself. Then from that point on, you can try to identify what are the right ways of organizing your workspace, naming your files, naming your folders, where to go where, and these things. It could be quite case specific to me. What about you, Richard?
Yeah, so I see here in the voting, there's been, most people separate things out into projects, which is a good thing. I guess that sort of makes sense. Because it gets more difficult when projects all blend together. What I always tell people is at the beginning of anything you do, separate out the data into different types of things. Because if you don't do that, then you get to the end and it's like you need to archive your things, but you have your original data all mixed up with tons of temporary files and you have no idea what to even archive or share or anything. And it becomes a big unmanageable mess. But yeah, so usually within my project folders, I'll have something that says it's a project folder. And then in there, there's original data, there's scratch data, there's code, there's manuscripts, and so on. So when I need to share or archive something, I can always find it pretty quickly. So what's next? This is a really cool one, automation. How is your research automated? I guess your research is sort of into automating other things, so you should have some good comments here.
Yeah, this is actually like one practice of that we've been thinking about in our group as well, at least that how would you employ some sort of way to automate your bits, let's say your build, creating your executable, or that's one thing, or even to run certain experiment, like what kind of libraries or software environment that you can use. I think the one that shown in the slide, I think that's let's say assuming that you use Python in an environment, but there are, I think, different ways of how to do this in different software environments.
Yeah. I mean, I guess in some cases, me coming from a sort of simulation kind of strategy, it is reasonable to have one command to run, and then it can rerun all the simulations, do all the analysis, and make all the final figures. But in some fields, if you're, say, controlling some other equipment or something, that might be a lot harder, and you sort of have to go and manually use the equipment and transfer data to another computer where it can be rerun and that kind of stuff. But yeah, so once I had a project and I actually did, so I used Make, which is a thing normally used for compiling software, but I used it to actually run all the simulations. And I could run one command and then get all of the final figures out. And the main thing I learned from here is I would not recommend using Make to do this kind of thing, unless you really like doing some esoteric stuff. But the thing is, there's many other frameworks that do these kind of things. I know many other Python frameworks, like you can read in this Code Refinery reproducible research lesson, but there's things like SnakeMake or DoIt or so on. I think I have an example of SnakeMake here. Yeah. So here I basically, well, this actually comes from the SnakeMake tutorials, but it shows that you define these rules and you say what is inputs and outputs and what commands to run. And then you can basically say, I want to do everything. And then it says, I need to make this figure. And then there's some rule that has an output that's figure. And to make that figure, that rule has other inputs. So basically it chains all the rules together to do whatever you need as the final output. So if you can get to this level, it's really nice, but it's something that at the beginning of projects, unless you know the tool well and just are interested in it for fun, you might not actually get to it. Please remember to vote if possible. So what's next? Reproducibility of the environment. Is this an issue in your kind of research? Maybe I should explain what I mean by this. So the dream would be to have one particular piece of software and you can just compile it and run it and that's all you need. But in reality, you have to depend on other things because most of the things that you do, someone else has made some basic tool for it. So when you write your program, how does it know what other tools are needed in order to run it? And these are dependencies. And in Python, that takes the format of libraries that you import. And you may or may not actually document these things. So the dream, like here, I've gotten an example from Python. So in Python, you have a requirements.txt file. And here's an example from one of my friends' GitHub projects. And you see, these are all the other libraries that need to be installed. So I know that I can take this program and then make a virtual environment, which is a Python thing for installing software, and tell it install all of these things. And then I'll be able to run the software, hopefully exactly how they did it. On the right side here is another example from Docker. So Docker is basically an operating system inside of operating system. So you say, we're starting from Ubuntu, which is a form of Linux, and we define some metadata, and these are the steps to install this operating system to run your software, which means that in theory, it is completely reproducible, which is a really nice thing to have. So yeah, how do you do this?
Yeah, I think like for my group at least, we're looking at going from level 0 to level 1, at least now. We're trying to improve documentation. That's, I think, the very fundamental starting point. Like you try to note all of the dependencies that you use, including the versions, and then also the steps on how you reinstantiate the environment. So that's kind of like what have been done a lot, or at least recently. But now we're also looking into a containerization with Docker. That I think that's one very interesting approach, that you can just use the script in Docker file, and then with one kind of like almost like a turnkey solution, then you can just reproduce everything in one click or one push of a button, and then it will run.
Yeah, I have some of my own opinions about dependencies and how accurately you should specify them. So one thing I often say is that if I want other people to reuse my software and it should be mixed with other things, you should not state the dependencies too accurately. Otherwise, then it's not mixable with other things that specify dependencies very accurately. And resolving all these dependencies becomes a really big deal sometimes.
I'd also want to add a few, one comment that also in scientific computing nowadays, the singularity containers are the standard for doing like reproducible research, because like in Docker, there's various different things that might create reproducibility issues. The main being that the underlying layer, for example, in the Docker file that Richard presented, it used Ubuntu as a base layer. That might change underneath basically the image, and so afterwards you can't anymore rebuild the same image. So there's various of these things, and this singularity container is meant to solve many of these things. So it packages basically the whole environment into a one container file that you can, for example, share with your publication, and then people can run it on whatever system they have.
Yeah, great. By the way, Simo's part of my team and is dropping by to see what we're talking about. So we're learning from the expert here. Okay, next up was documentation, which is something that we all like to complain about a lot. So yeah, documentation seems to be the thing that people always leave for the last minute and never do. But luckily, you don't have to be completely perfect for things. So even making a simple README file that explains what the project does and how to run it and adding the most useful notes there, that's enough for many of the small things. Let's see, do we have a documentation example? Yeah, here we have several examples. So here's actually one of my old projects that has no documentation whatsoever, and no one else could possibly use it or even know what it, like how you would get started there. Here's an example from Udinyanto with a pretty extensive README file that explains everything that goes on and how to use it, which is what I'd say most programs should target. And finally, we have NumPy documentation, which is a massive piece of work that explains everything about it, from tutorials to guides to API reference and so on. How would you say your group fares here?
Yeah, like this practice of putting readmes have been kind of like mentioned often in our discussion internally, at least, and also to our students. Like we try to, let's say, employ some for the students and for exercises, like because let's say if they want to aim for careers, let's say in software developers, or even later on if they themselves as a researcher, then having this try to kickstart the habit as at least from the beginning, it's usually a good way to start with.
Yeah.
And as you said, like having a simple README could be a start, like just to explain what the code or what is the implementation is actually doing. Of course, like if you aim to, let's say, have a documentation at least for yourself or for others to completely reproduce or re-execute everything, hopefully as close as possible to the actual specification, then you would provide all of this very detailed documentation. And the example that I put there, it involves different software environments, so which is probably one reason why it can be very extensive. But if your work involves, let's say, only a few of these software tools, then probably may not be as extensive. That very much also depends on the work itself. And
do your group leaders have standards for documentation and expect people to do things of a certain level?
Yeah, I think when we're talking about like the condition of the group overall, I think that will take time. But for us, like we start from something simple and then see if we can kickstart something bigger in our group. Like we have a more consistent practices that we have. Most of us or every one of us would start to, let's say, use this practice more in their work. Changing habits and changing the situation will take time for sure.
Yeah. So next is something that we all like to talk about, which is testing. So there's a somewhat well-known crisis of reproducibility in science where most results can't be reproduced, at least in some fields, and software makes it even worse. So how easy is it to have a simple software bug that makes all your results wrong or different? And you read the stories about this and it's just horrible what you see. So some sort of testing is basically required in order to ensure that things work. And the main point of these levels is that you can go from some sort of like, well, clearly all software is tested at least when it runs. Like you write something and then you run it on a test case and you see, is the result right? But do you run this once when you first write it, or do you sort of take this and script it so that way later on you can run all of your test cases later? And this is what's called either the automated testing or continuous integration when it's run completely automatically. And in this middle ground here is sort of defensive programming, where you sort of add in like assertions or tests inside of your functions to do some basic sanity check of the inputs or outputs or things like that. But here we have a very big testing example. So this is actually from NumPy again. And here someone has found the bug and it's been described in an issue and now they're fixing it. And then once they make the pull request, which we'll talk a little bit about more later, then it runs all of these different test suites on everything in NumPy in order to see if anything else is broken. And here we see it all works. And this is just such an amazing development. So making any one small fix can suddenly, they can test and make sure that nothing else is broken. NumPy is a pretty important package in Python. almost everything else in science in Python depends on it somehow. So you'd really hope that anything that gets added to NumPy actually works. And this is how they make sure that's the case. Let's see. No, there's no other example. So how do you do this?
Yeah, this is one kind of like big topic, I think, for us, for me at least as well. The automated testing is like a dream for me at least now, like as a long time dream that needs to be think about carefully, like how we want to deploy this practice, at least in some point, at least in the experience. Like we usually just use this manual testing, like we test on very, let's say, typical cases that we think would be the most often to consider. But then, like, if, let's say, as you develop your software over time, let's say at the first phase of your development, you test and it runs, but then after you put new implementation, new codes there, and then when you test it again, it's something that actually passed or works correctly, may not work correctly again after you add more things.
Yeah.
This regression testing is probably one kind of like thing that is important.
Yeah. And this is something that seems complicated, but with modern tools these days, it's not too hard. And especially if you use GitHub or some other public service, it can basically do everything for you for free. And you need to define the tests and how to run them, which GitHub has a basically automatic way to enable these things. And then you can get these green checks that show you that what you're doing is actually working. Maybe we should go on because our time is running low. So next up is licensing. Why is the license important? So basically in modern society, anything that you might do is by default not reusable by other people, which means two things. Other people can't reuse your work and you can't reuse other people's works. And this is really not a good situation for science to be in whenever we should be all working together. And this is sort of the reason for the open science movement. So even if nothing else is perfect, all I can recommend is have a proper license, and then other people can always come and improve your things later. And that will only increase the number of citations you get. And there's some good examples here. So this first example comes from NumPy. So they've been very careful about saying what the license for NumPy itself is and what the licenses for the other included software is. There's sites like chooselicense.com that can sort of guide you through working or choosing a license. And when you combine different software, there's all kinds of requirements about what licenses can be mixed together. So here's basically a flowchart for what license can be included into other software. Then we get to distribution, which is how other people can reuse your code. How many people even distribute code? Like in your group, do people distribute things? by default, or if someone asks, or is it released, and so on?
For now, I think we try to kind of like promote this practice to, let's say, publish it if possible. Of course, like there are some situations where the projects could have some IP restriction, or let's say possibility for commercialization. So there are some consideration if you want to distribute some of the result. But if the project is doesn't have that kind of nature, then we usually advise or recommend to, let's say, put it in Git repository, make it available publicly, and put the appropriate license. For a license, we usually consider something like Apache 2 or CC BY 4. But usually it appears that we really like this Apache 2 for some reason.
Yeah, it's become quite popular these days. Anyway, we have only 2 more topics and are running short on time. Here's 2 distribution examples. So here's a release on GitHub. So it's on GitHub and it has a release, and through some GitHub and Zenodo integration, it can appear on Zenodo with a citable DOI and all of that stuff. So next up is reuse. So how often is your code reused? And actually, this is about the other way around. So how much do you reuse other people's code? Do you keep reinventing things, or do you take the best practices and use them again? Like once I went to some collaborators, no, it wasn't mine. I heard that someone said, okay, this other group, before they start a project, they go and they sit down and they research everything that everything that exists, and then they start working, which, you know, sounds sort of obvious, but when you think about it, I think many people don't really do stuff like that. Like, how often do people start working and then keep reinventing things that already exist and thus waste a lot of their time?
In certain cases, it could be a bit of dilemma. Like, let's say you find some existing tools, but then the documentation is not enough.
Yeah,
that's
yeah, that's like all the other things we talked about. So, you know, someone else didn't do their job in releasing something and documenting it, and now you can't do it, so you have to reinvent.
Yeah, so I mean, when you arrive in that kind of situation where the documentation is not enough, so either you study yourself and try to understand it as much as possible, or you just, you know, say that it's I'm not sure if I can get or I can understand this correctly, so I'm just gonna reinvent everything myself. So either you go that one direction or the other direction.
Yeah, that actually brings us to the last topic pretty well. So someone once said, if you, so this person worked in water, like water modeling, and they made the good point that if you take and you have some model and it's a closed model and you don't share it, someone else is going to come and not be able to use it. So they'll make another model and they'll actually open it. And then since it's open, more people will be using it and citing it, and the open version always wins. And that's why this sort of collaboration is so important. So if you're working alone, then you're reinventing everything and other people are not adding to your work. And the people that take a project, so many of these tools that we rely on so much started as small research projects that someone did. And then just by the virtue of being open, they got more and more contributors, and they worked their way up to this community project welcoming contributors, and were able to really reuse, like become sort of the worldwide standard for a certain field, and thus get all their citations. you have any thoughts on this?
Yeah, collaboration also depends on the situation of the project you're working on. Like, I'm aware that, let's say if there's a European project where you have different collaborators in different organizations, then they may have this they have set up this environment for collaborative work. Let's say in the Git, you can put commits together, you may make pull requests, merge it. So they would have something like this, or expect to have something like this. But for, let's say, a project which is of smaller team or even individual project like PhD, then probably you don't see this very much. But yeah, that depends a lot on the project sometimes.
Yeah. So now we're coming to the end, and there's a discussion. So by now most people have left, but we can ask, how do you want to improve your software in the future? Like, which of these sort of strategies that we've talked about are suitable for your work? So as I tell people, don't try to do everything perfect, but look at these things and try to make some of these topics a little bit better where it will have the best impact to you. Start using version control. Yes, that's a very true thing to do. Version control basically makes a lot of these other things possible. Like almost all of the other examples we gave were somehow integrated with version control to track it and share it and make it worth it.
If I can say one thing, probably it's start from, if you don't have much, you don't have have practice in putting documentation, and start putting that. Maybe start from a simple README. That also could be a one step. Yes, it's also mentioned that improve documentation.
Yeah. Yeah.
And also putting license. It's the templates are around. So as you also show, like there is this one platform where you can define your needs, and then it will show you the appropriate license.
Yeah.
So license just basically take that what is suitable and then put it in the repository. That's
Do you have any advice on going from, like, let's say there's a group with people working individually and they want to transition to working together? This is a really hard jump, and most of the groups I've been, while we've tried to do this, the jump hasn't really been made. And I don't know if it's because like we have different levels of expertise on the version control, or our projects are too different, or maybe it's that people start to work together, but like at any point, some other paper revisions could come up, or something else urgent happens, and then someone has to take some time to do a different project, and then the remaining person says, well, no, I'm alone, so I'm just going to do it myself, and then like the effort at collaboration fails. Do you have any thoughts on this? Because really, I don't know what I would do here.
Yeah, that's a good question. That depends very much on also the circumstances of the projects, as you mentioned. But could also be a matter of communication. So, but starting small and see how it goes, probably. But we haven't actually have a lot of experience in collaboration within the team because of the circumstances of the project. Everyone works with their own project, and so it's a bit, hard to facilitate this collaboration.
Yeah. Yeah. Well, maybe we should wrap up. Perhaps we can stop the recording and see if